Dr. Tom, and today I'll be demonstrating an experiment called disappearing ink. This experiment helps demonstrate an acid-base reaction or neutralization reaction. This type of reaction takes place when an acid and a base are placed together, generally in water. Here with me today I have my good friend Bob. Bob, if you would like, you can come out and introduce yourself.
Howdy, y'all.
Now Bob, today we'll be demonstrating an acid-base reaction.
Acid? You mean the type of stuff that eats your skin?
Well, no, Bob. Only some types of acid do that. An acid is a substance that ionizes in water to form hydrogen ions, and a base is a substance that ionizes to form hydroxide ions. In this experiment, when we combine an acid and a base, they will react with each other to form water and a salt.
Finally, a word I understand. Salt. Ain't nothing like a good salty meal.
Well, no, Bob. Actually, the type of salt that we made today isn't the kind that you can eat. That's sodium chloride. In chemistry, salt refers to a compound formed when an acid reacts with a base. Today's acid-base reaction will be creating sodium carbonate.
So you're gonna put the acid that doesn't eat your skin in the water, and that makes some science stuff. And then you put the base in, and that makes some more weird science stuff. And then it gets together and makes the salt that you can't eat. And then some more water.
Well, yeah. In today's experiment, I won't be doing exactly that, but you get the idea. For this experiment, to make the disappearing ink from scratch, you would need ethanol, sodium hydroxide, and thiamopsilene solution. Also for this experiment, I will need some paper and a Q-tip to spread the ink onto the page with. So what you do is you take the ink and you dip a Q-tip into it. Then, using the Q-tip, you spread the ink onto the paper like this. See, now if you watch closely, you see the ink begins to disappear. And just give it a minute, and it should completely disappear.
Well, I'll be darned, it disappeared.
That's right, Bob. And the reason the ink is blue is because of the pH indicator in it called thiamophthalene, which is blue above the pH of 10.5 and is otherwise clear. The reason the pH is above 10.5 and the ink is blue is because of the base in the ink called sodium hydroxide.
What the heck is a pH?
Well, Bob, to put it simply, a pH is the way to measure the acidity if a solution has an acid in it, or the alkalinity if the solution has a base in it. If the pH is above 7, then the solution is considered to be alkaline, and if it's below 7, then it's considered to be acidic.
Well, if the soda hydroxide makes the ink turn blue, then how come the ink turns clear? What's happening to the soda hydroxide?
Sodium hydroxide, Bob. Sodium hydroxide. And the reason the ink turns clear is because of a chemical reaction. When the ink is spread out on the page, carbon dioxide in the air is absorbed into the ink to create carbonic acid. Do you remember what I told you earlier about acids and bases?
Yeah, the weird sciencey stuff.
Exactly. Well, what happens is the carbonic acid and the sodium hydroxide react with each other. And after this reaction occurs, all that's left is water, sodium carbonate, a salt, and thiamophthalene, the pH indicator. And at this point, the pH is less than 10.5, and so it turns clear. And that's why it disappears.
This stuff is really interesting. I can't wait to tell all my friends. Sure beats using urine as invisible ink.
Well, Bob, I'm sure glad you enjoyed it. And I hope those of you watching enjoyed it as well.